So today we're going to talk about DataLad, which is a version control system for large data sets. It's built on top of Git and Git Annex, and it was written in Python, but it's available both via command line, so Unix command line, as well as a Python API. And it is an open source project. So it started a few years ago, and it's funded by research grants from the US and from Germany. So let's begin with Git. So I assume that most people here already know Git. We'll have to talk about Git because DataLad is built on top of Git and Git Annex. So Git is a well-known and loved version control system for keeping track of text files. So originally designed, 16 years ago for keeping track of the Linux project. Now it's used, by millions of different text-based projects. So whether you are coding some software, or you're writing a thesis, or you're writing and collaborating with your colleagues on a research paper, Git is really a fantastic tool. And I assume that most people are familiar with the basic Git command, so I won't show them now. But basically, Git is really, really good for keeping track of, large projects, text-based projects, of collaborating with people, merging commits made by you and by your collaborators into the common project, etc. What Git is not so good about is working with large files for two reasons. One of the reasons is that when you try to commit a large file to a Git repository, what will happen is that, let's say you're in a working directory, we also have the Git repository inside the hidden.git excuse me, subdirectory. What will happen is that a copy of that large file will be stored, of course, in your working directory. So since you're working with that file, as well as there's also a copy in the .git directory. So there will be two copies, at least two copies of the file. And if the file is large, if it's several gigabytes, for example, then obviously you'll be wasting a lot of space. The second problem, and so once you start modifying these large files, then we'll have new versions, and you have new versions of gigabyte-sized files. So obviously, your disk space usage will grow very quickly. And the second problem with keeping version control of binary, data files is that very often they are not text-based; they're binary files. And binary files don't really have a well-defined, lines where you can track for changes. So in Git, for example, with Git, for example, when you keep track of a text-based file and you make a change in that file, Git will tell you immediately, okay, in this line you made this change, and so it doesn't have to store, the new version of the file. It can store just the change. Whereas with binary files, it is much more difficult to do that because, lines are obviously not defined inside binary files. So this is where Git Annex comes in. Git Annex is a popular project that was started about around 10, 12 years ago. And the idea here is use Git underneath, but replace large binary files with symbolic links. So symbolic links are actually still being tracked with version control, with Git version control in Git Annex. But large files, so these symbolic links are pointing to the actual large files, perhaps text files, perhaps binary files, and these large files are stored elsewhere. So they could be stored locally inside the .git directory, or they could be stored somewhere else, even on a different computer, different drive, etc. So they don't have to be stored locally, which means that you can actually save some disk space. So DataLad builds on top of both Git and Git Annex. And it adds a few new, so it keeps everything that Git and Git Annex provides. And in fact, today we're going to be using all three commands, Git, Git Annex, and DataLad heavily. So we'll be using functionality of all three layers. But also DataLad provides a few other features. So one of them is datasets or repositories inside DataLad can be nested. So you can run commands at the top or parent level, top level dataset or repository with a -- recursive flag. And that way you can, for example, update all sub-repositories or sub-data sets in a single command. And we'll see at least one example of that today. DataLad can also run commands on data. And if your data is missing in the sense that there's no local copy, but there's a copy somewhere else, let's say on the web or on another drive, then DataLad is actually smart enough to pull that copy and process the data. And of course, I'm going to show you some examples of that. So you don't have to download the data manually. DataLad can also keep track of data provenance. So for example, there's a command datalad download URL, which will grab a file from a URL, from the web and download it to the local directory, but I'll also keep track of the source of that file, so that when you run, for example, git annex queries command, it will tell you there is a local copy, but there's also a copy at this web address. So anyway, so let's just get started with. I'm going to be showing lots of demos today. So I'm going to be, sometimes typing, sometimes just copy and pasting from these notes. So in terms of installation, it really depends on your machine. Sometimes it's quite easy. Sometimes it's a little bit more involved. So in my case, I'm on Mac OS, so I already have Git installed, in the system directories. And all I had to do on my machine to install DataLad was to install Homebrew, which is a popular package manager for command line utilities in macOS, and then I simply type brew install git annex to install the git annex dependency, and then brew install DataLad, and that's all I had to do. So sometimes brew is not available. Maybe you're not on macOS, you're on Windows or on Linux system. So in that case, as I mentioned, DataLad is a Python package, so you can install it through Conda, through pip. So pip, the famous Python package manager. And typically you would do something like pip install DataLad or conda install DataLad. And there's a detailed page which covers various scenarios depending on the operating system. So I just refer you for further installation instructions to this page, which is linked from my notes. So on the clusters, it's we don't have DataLad installed centrally, and by clusters I mean the Alliance HPC clusters, so clusters like Cedar, Graham, Narwhal, Beluga, and others. We don't have DataLad installed centrally, but you can install it very easily yourself through a Python virtual environment. So in this case, we already have git annex installed. It's just the only DataLad that you need to install on a cluster. So I would typically load a git annex module, then I will load a Python module. I will create a virtual environment. So in this example, the virtual environment will be placed into the subdirectory in my home folder. Then I activate this virtual environment. Then I optionally can upgrade pip, Python package manager. And then I simply run pip install DataLad. And that's all I need to do to install it. And then I can deactivate the environment. And in my experience, you don't actually need to have keep the environment active to use DataLad. All you need, and I haven't seen any problems with this, once you install it, this environment, you simply create an alias to your DataLad installation. So in this case, it's in my home directory, DataLad env bin folder, and the alias will just do everything for you. So next time you log into the machine, you'll need to load the git annex module, because you need the module to actually work with annex data, and then having this alias, for example, inside your .bash.sc file will do the trick, so you don't have to define it every time. And one thing that I recommend, if people are looking at DataLad to collaborate between research members of the same team, the same research group, then it's probably easiest to install DataLad inside your shared folder in the project directory. So on each cluster in Compute Canada, in the Alliance, we have the shared project directory where everybody is part of, let's say, dev, dash, and then some sponsor PI username. So all users belong to the group that has this name, right? So that means that all of them can actually read and write into that directory. So in that case, I would simply suggest using exactly the same procedure, installing a virtual environment with DataLad into a shared project directory, and then everybody in that research group will be able to run DataLad from that single installation. Let's get started. So let me show you some demos. So the way this webinar is organized is I'm going to walk you through the textbook introduction to DataLad. So I'm going to follow closely the online tutorial at datalad.org, but I'm going to simplify it much simpler. So I think that will probably take me around 20 minutes or so. And then I will jump into 5 scenarios. And most likely I won't be able to show you all 5 scenarios, but I'll talk about them and I'll show you maybe a couple of demos. So let's get started. So first, we're going to create a data set, and I'm going to go into a temporary directory, TMP, and in this directory, I'm going to run the following command. So what this command does, it creates a new DataLad data set. So optionally, you can provide a description. You don't have to, but here I simply call this data set our first data set, and then it's going to go into a directory called test. So there's going to be a test subdirectory inside the TMP folder. And then I'm providing what is called a DataLad configuration. So depending on your DataLad installation, you might have access to different configurations. What these configurations do is they describe which files should be kept under regular Git version control, and which files should be kept under Git Annex version control. So these files, when you commit them, contribute them to the dataset, they will be replaced by the symbolic link, and the actual files will be copied elsewhere, right? So basically, this text to Git profile means that everything that is a text file will be put under regular version control, will not be annexed, and everything that is binary, for example, a PDF is considered a binary file in this system, will be put under Git Annex version control. There are several other configurations as well, so you can read about these in the online DataLad tutorials. For example, no Annex configuration obviously doesn't use Annex at all, so it puts everything under Git version control. And then there is a YODA configuration, so I link it from the notes. There's a fairly long description, so I'm not going to use it today. So let me copy this line and move actually my notes out of the way. So here I'm going to create a test. Oops, it's already created. Let me delete the previous one. Oops, I was testing things this morning and I forgot that I actually need to remove the old one. So user, that's right, test. And then let me remove it. Okay, great. So I'm going to run the following command. The command will create a new DataLad dataset inside the test directory. So now you see there is a test directory. If I go into test, I do ls. You see there's the familiar.git repository that comes from Git, but there are also a couple of DataLad specific repositories. So one of them is a Git attribute. So this is where your profile is stored. So for example, how we're using Git Annex. And there's also the .datalad directory, right? So these two directories are specific to DataLad. So inside DataLad, you can use the familiar git log command. So if I type git log, you see that there were two commits when I ran DataLad create. One is I created a new data set, and the second one I instructed Annex to add text files to Git. So everything that is not text file will be kept in Git Annex. So let me show you some examples from the official DataLad handbook. I'm going to create a directory called books, and then I'm going to run a wget command to download a file, a PDF file. It's actually a tutorial on the Linux command line. So I'm downloading this file from this location, right? And this command wget is the usual downloading command. It doesn't have anything to do with DataLad, right? So I'm downloading the file from this online location, and I am putting it into the books subdirectory into this PDF file. So when I do this, it will run. And then if I do ls, you see there is the books directory. So inside the books directory, I now have this PDF file, right? So a PDF file. So in fact, I can actually open this file, right? So it opens right here. So it's a Linux command line tutorial. Great. Let me download another file and also put it into the same books directory. So this time it's a Python tutorial. Okay, and now this file is also inside the same books directory. So now we have two regular PDF files inside the directory. All right, let me run the DataLad status command. So this is very similar to Git status. So here you see that we have now an untracked books directory. And inside this books directory, we know that we have two PDF files. So we're going to save these files. We're going to run the DataLad save command with the -m flag. So -m flag is followed by comment. Added a couple of books on Linux and Python, right? So everything is so far very similar to Git. So instead of git commit, we run DataLad DataLad save. Right, and notice that here we don't have an equivalent of a git add command. So by default, DataLad save will find all new files and all changes, and will commit those changes to the repository. So now let's see what's happening inside the books directory. So now you see that previously we had two PDF files, and now these PDF files were replaced by symbolic links, right? So the reason for this is because these are not text files, these are binary files, and binary files are kept inside the Annex. So you see, you can actually run ls-l to see where these files are stored exactly, right? So they are stored inside the .git repository, right? But they're replaced now by the symbolic links. And of course, symbolic links work properly, so in the sense that we can still open this file. So for example, a byte of Python, I can open it and it opens just fine. All right. So now if I run git log, you will see that now I have a new message. So the latest commit was added a couple of books on Linux and Python. And by the way, with git log, you can also give more specifics. So for example, if you have a long history and you don't want to see the entire history, you can say only show me the last commit. -n1 will show you only the last commit. If you want to get more details on this commit, you can add the -p flag. And -p flag will actually show you the files that were eventually stored in the Git repository, right? Also, I personally like using a more complex command that shows just one message per commit. And the way you can configure this command is by running the following git config long command. So I have it in the notes. You don't have to look it up now. But the idea is that from now, if I want to do git log and see a nice printout, I can actually run git 1 and I get this nice printout. So you see there were 3 commits, right? We initialized the repository, we instructed git annex to add text files to repository, and then we added a couple of PDF files on Linux and Python. All right. So let's add another book, but this time I'm going to do it differently. So I'm going to download it from an online URL, but instead of using wget command, I'm going to use the datalad download.url command. And what this command does, not only will it download this file from this location and put it into a PDF file inside the books directory, but it will also commit this new file to the datalad repository. Right, so here I'm saying that added to the current data set. Dot here means not current directory, but means current data set. So download this file, add it to the current data set, and commit it to the repository with the following commit message. So edit the reference book about Git. All right. So now when I do this, and if I do git log now, you see that now I have a new commit, right? Added a reference book about Git. If I want to get more information, I can run -n1 -p command, and it will tell me that this new file actually went into this annexed file. Now, if I want to see, if I want to check whether this file is stored locally or not, I can issue the following command: git annex, where is, followed by books, and then it was the pro-git PDF, right? So the following command, git annex where is, followed by the name of a file, will show you where this file is stored. And in our case, this file is actually stored in 2 locations. So we store it here, right? So a data set called our first data set in this repository. And also there is online location on the web, right? So that's the whole idea of datalad download.url command, is that it also keeps track of the web location. And the web location is actually this URL, right? So this is where we store the file from. Remember previously, if I run my history, previously, we also ran a wget command, for example, on this file, right? Right here, the Linux command line. And now if I try to do where is on the Linux command line, so the Linux command line PDF, you will see that now it shows only one location, and that is because I use wget there and not datalad download.url. So the last command also stores the URL from which I downloaded the file. All right, you can also run git annex where is by pointing it to a directory or not supplying any argument at all. Then it will just go through all annex content. So for example, I can say git annex where is books, and then it will show where everything inside the books directory is stored. So all of these guys are stored locally, right? And then for a couple of these guys, I also use the download-url command. So I also have the web URL recorded as well. Okay, any questions at this point? So we're just going through the canonical introduction. All right, if there are no questions, then let's create and commit a short text file. So please, I'm gonna, yeah, there's a question, somebody.
Is it possible to migrate this stuff? Like say that down the line, the web address changes? Is there,
I don't know if you can remove the web address. You can change the web address. Yes, I'm going to show you how in one of the examples I run, how you can add your own web address to a document in this format. I'm not sure if you can erase an old address. I don't know whether that's possible or not, but you can certainly add new ones for existing files, new URLs. All right. So let me create and commit a short
Alex?
text. Oh, yeah.
Yeah, I'd be surprised if you can't remove the web address because you have all the data has been downloaded.
Yes. So the short answer is I don't know. I have not tried, but I won't be surprised if you cannot, because what DataLad tries, the philosophy of DataLad is to keep essentially entire history of your project and to keep provenance of everything that's been, you ever touched. That's the whole philosophy of DataLad. So knowing that,
sure, no,
I
understand that, but because it creates a local clone of the data when you download it. Of course, if you don't download it, that.
No, you can remove the file for sure. Yes, you can remove the file, no problem. So
no,
we'll see
no,
lots
no,
and
but
lots
I mean,
of examples of that.
Yeah. No,
but whether you can remove the URL, I honestly don't know.
I think so, but I haven't tested it. That's my guess. That's all. Yeah.
All right. So let me create and commit a short text file. So for this, I'm using what is called in Bash a here document structure. So here inside into this file nodes.txt in the current directory, we are simply writing a single line, right? So if I do cat on this file, then we have a single line. We have downloaded 4 books. And now if I run datalad status, it will show me that there is a new untracked file. So let me add this file by running datalad save -m and then a commit message added nodes.txt, right? So now that if I do git log, you will see at the top now I just added nodes.txt. Okay, and when I do this, you see that because nodes was a text file, it actually doesn't go into the annex. It's stored as a plain text file right here in the working directory, even though it's been added to the datalad repository. All right, so let's now add a couple of sub-data sets. So a sub-data set is essentially a nested datalad repository. So for that, I'm going to clone an online data set. So now I'm using datalad clone command that I have not seen before, but it's actually very similar to a git clone command. So here I'm cloning a datalad repository from this online repository, machine learning books, and I'm putting this into the current data set, right? So it's going to be stored in the subdirectory, basically as a sub data set inside the current data set. So let me run this, and let me do tree now. And you see there's a new subdirectory called machine learning books, and inside the subdirectory I have a whole bunch of symbolic links, right? So you might ask, well, were the files, were actual files, PDF files themselves downloaded? And there are multiple ways of checking this. So you can run du -s on machine learning books that will show you disk usage, and you see that it's only hundreds of kilobytes. It's very small. So most likely the files were not downloaded, but there's actually a command to check that. So you can say datalad status --annex, and it will show you disk usage for your for a specific for the entire project or a specific directory or for a specific file. So in this case, it shows there are 3 annex files, right? And these files should be 16.5 megabytes in total. So in fact, let me actually go into machine learning. I think that command makes much more sense here. Yeah. So inside machine learning, because I ran git annex previously in the current directory and it didn't apply to the machine learning sub data set. So now I switch to machine learning books directory sub data set, and then I run datalad status annex, and I show that there are 9 annex files, right? So PDF files in machine learning, and all of these files, if they're stored locally, they will take 16.5 megabytes of space, right? So let's check if they're actually stored locally. And for this, we are adding all to the previous command. So what all will do, it will simply go through all the files, whether they're stored locally or not locally, and will show us disk usage. And so what it tells us is that out of 74.4 megabytes of data that you would expect to have in this directory, 0 bytes are stored locally, right? So that means that actually none of the files that we cloned before, they were downloaded, right? These files are actually still online, but now we have local knowledge about these online files, and then we can run a datalad get command to actually download those files. Before I do that, let me actually show you that you can also run git status annex all command on a particular file. So for example, let's say this file, we're interested in this file. So this file, if we had it locally, it would take almost 700 kilobytes of space, but because we haven't downloaded it, it takes now, well, 0 bytes. Okay. So now, if you want to download the file, well, let's run the datalad get command. So I'm going to say datalad get followed by the file name. And now it will download the file. So now if I run status, now I will show you that out of 700 kilobytes, 700 kilobytes present here. So the file is actually present here. Another command to verify that the file is here. Git annex has a whole bunch of commands. Well, it's actually a single command, where is, but it comes with a bunch of flags. For example, I can run git annex where is, and then I can supply the file name, and it will tell me where the file is. Well, you've seen this command before, where the file is exactly. So there is a copy on the web at this URL, and then there's a local copy. Let me instead of running git annex where is on all local, sorry, on a single file, let me try to run the following: git annex, and then I'm going to say, I forgot the syntax. Yes, in here. So you can either run git annex find or git annex where is. I think both commands will work. So here I'm simply listing all the files that are stored here. If I want to store list all the files that are not stored here, I'm going to pass the --not flag, and then it will only show the remote files. And I believe this command actually works with where is as well. So let me try. Where is, yeah, that works as well. So it will show, the provenance for all files that are stored locally. Okay, so this file was downloaded previously with the git annex, with the datalad get command, right? So that means that we can actually open this file and display this book locally. It works fine. Now, if I want to drop the book, the command is datalad drop. So it will delete the local copy. Right now, I cannot open this file because it doesn't exist. And in fact, if I run git annex on local files, now it doesn't show anything because, well, I just deleted the local version of that file. Now, if I run git log, notice that none of the stuff that I just did in the past few minutes with downloading books actually appears in the git log command. And this is because we cloned a remote repository, but we have not made any modification to the repository, right? So what we've done is we're basically, looking for, querying the file provenance and then downloaded the file, then deleted the local file, but we have not modified the repository itself. So inside this machine learning, subdata set, the latest commit goes back to April 2019, right? So none of the stuff that I just did actually shows up. All right, so let me go through all remote files, and actually all the files right now are remote, right? All of these files are not present locally. So here I'm listing all remote files, and then I'm going to cycle through them. So I'm going to organize a loop. I'm going to run a script, write a script with the here document syntax, right? So inside the codes, actually I need to probably create the code subdirectory first. So code subdirectory, I just created a code subdirectory. And then into that subdirectory code, inside the titles.sh file, I'm going to put the following script. So let me show this file, codes titles.sh. So here what I'm doing is I'm going through all annex files that are stored remotely, that are not present locally. And then for each of the file, I'm taking the file name, and then I'm getting rid of everything before the dash. So I'm getting rid of the author name, right? And then I'm getting rid of the PDF, the final PDF. And then I'm converting all underscores to spaces, right? So what I'm doing here is basically I'm going through all these books that are stored remotely and extracting their titles without, the author name and without the PDF and without the underscore, right? So here I now run datalad status, and because I just created a new file, a new directory, and a file titles association of the directory, now it says that, well, the directory with everything inside of it is now untracked, right? So let me save it. I'm going to run datalad save. I'm adding a short script to write a list of book titles, right? So here we go. Now, if I do ls on codes, you see that titles.sh was actually annexed. So datalad is not the way it looks at text files. It actually interpreted this as not a text file, it's a binary file. Not sure why it did it, but I guess maybe it looks at the extension.txt, or I'm not sure exactly. But in this case, it's actually curious that it decided that it's a binary file, but not a text file. But anyway. So the next step is we're going to run this script, right? So we're going to run this script to actually extract the list of all book titles. So I'm going to run this script, but instead of running it directly, right? So I could, of course, run it like this, for example, bash, bash followed by the path to the script. Instead, I'm going to run it inside DataLad. So I'm going to run the command datalad run, where I'm passing comments. So in this datalad run step, I'm creating a list of books or book titles. And then the actual script that I'm running is at the end of this datalad run command here in quotation. So I'm actually running the following bash script. So bash code, so run the script, and then take all this output and put it into the list.txt file. Okay, so let me run this. And now I have the list.txt file. And interesting thing that this file was also interpreted as a binary file, not as a text file. But if now I look at it, at this file, you see that this file contains the output from my script, the titles of all the 9 or 10 books, right? And now if I run git log, you will see that also I have a record of this run. So the previously I added a shell script to write the titles to the repository. And then in the last commit, I actually have the output of the run, right? So here it has the full provenance, full information about the run. For example, it lists the command that was run, it lists the, some other stuff. Well, there are no inputs or outputs. You will see them shortly. But basically, everything, all information about the run went into the history of my DataLad project, as well as the output list.txt is also now part of, it was committed to the repository. All right. So now I'm going to modify and rerun the script. So let's say I'm not happy with the script. For example, I'm not happy with the fact that all these titles, I want to include them into double quotations because, well, they're titles, right? So instead, I'm going to run a different script. I'm going to modify my script. So my script, it will still be stored in the same file, code titles.sh, but the script is now going to be different because I'm going to place each title inside double quotations, right? Okay, so let me run this and actually see that now I get permission denied. And the reason for this is because our script, titles.sh, it was actually stored in Git Annex. It was Annex, as I showed you before. And you cannot modify Annex files without unlocking them first. So the first step, you need to actually unlock this file. So I need to run datalad unlock, and then on the titles.sh, and then I can actually modify the code. So here I'm modifying the code. Now here's my new code where I'm placing each title inside double quotation. And then I'm going to save this with datalad save. So I'm saving the new script, right? So correction includes titles into quotations. Okay, great. So now if I run git log, you'll see that my correction is now part of the last commit. And now I'm going to run it. But instead of running datalad using datalad run, I will actually use datalad rerun command. And so notice here's the hashtag from the latest run, right? So I'm going to copy this, and I'm going to say datalad rerun this previous run, right? So I'm rerunning this guy by simply passing his hashtag to datalad rerun. And I don't supply the command, don't supply input, output, that's all I do. And now if I look at lists, now you see that my list has the new result with quotations. And if I look at git log, you will see that it now has information about the new run as well. So this is the new run. Oops. This is the new run. This is the old run, right? But the whole idea is that now DataLad has full provenance of everything I've done before. So it has a copy of the new list. It has a copy of the old list if I want to get it. But as I mentioned, the philosophy, the central philosophy of DataLad is to store everything. And then you can easily go back to the previous versions if you want. All right, so finally, let's extract the title page from one of the books. So let's pick up the book that we saw before. This book, remember that we deleted a local copy, so it doesn't exist locally. And but still, that doesn't stop us from running a script on top of this book. So the way I'm going to run this script is I'm going to run the following command. So I'm going to say datalad run, and then the comment, so extract the title page from a PDF. And then for the input to the script, I'm going to use this file that is not present locally, right? So it's not stored locally, it's stored somewhere, online. And then the output is going to be a one-page PDF called title.pdf. And then this is the actual command I'm running. So I'm taking the input, I'm taking this input file, right? And I'm running convert minus density 300 dpi, converting into extracting a single page. And at this quality, if there are any embedded images at this page quality, I am writing things into a title.pdf file. So let me run this. Oops, it said diode of signal 10 failed. Not sure what was wrong. Let me try it again. Okay, great, it worked. So I didn't copy something properly before. So it worked, right? And now there is a new file title.pdf that was actually committed. Right now, if I open title.pdf, it's actually the output of our last script. Now you can actually see that it's a one-page PDF, so I can list through it, and it contains the output of our script. And then conveniently, it also downloaded the input PDF that required to run in order to run the script, right? But if you don't need it, you can actually drop it, right? So you can run DataLad drop on this guy, and then it's no longer present locally. Okay, so are there any questions at this point? Any other questions before I jump to the workflows? So we have roughly 20 minutes left, and the workflows that I wanted to show are the following 5. So 2 users working on a shared cluster file system with the same data set. So I think I'm going to start with that. I'm actually going to show it. 1 user, 1 data set spread over multiple drives. Maybe I won't show it just because we don't have enough time, but it's actually a very interesting usage, per se. So I use it myself all the time. I have lots and lots of, various flash drives, hard drives, SSDs scattered around in my desk drawer, and then I never remember what is stored where. So I actually initialize a common DataLad repository where from each copy of the repository, for example, from a local copy on the laptop, I can actually see where all other files are stored, which is really, really convenient, even if those files are not currently mounted. Another one is publish a data set on GitHub with annex files in special private remote. So maybe I will talk about this if we have time. Another one is publish a public repository on GitHub with publicly accessible annex files on Nextcloud. So here the idea with these 2 use cases is that with GitHub, you actually have restrictions on how much data you can upload, right? So obviously you cannot put 100 gigabyte files simply because GitHub will not allow you to do that with a free account. But with, if you store your project as a DataLad repository on GitHub, you can actually store the annex files to the large data files elsewhere, either in a special private repository, so for example, an SFTP server, or on a Nextcloud, whether it's a public file on Nextcloud or private file on Nextcloud. You can do both fairly easily. And the last scenario is managing multiple Git repositories under one data set. So since I don't have a lot of time, so some of the stuff I will not show, but you can still access it through these notes, right? So there's a lot of information there. So let's start with the first case, working on 2 users working with a shared cluster file system. So for this, I assume that both users share exactly the same group ID, so they're part of the same research group using the same cluster. But of course, you can do something similar using access control lists. So this is a more complex setup if 2 users come from different research groups. But I'm going to go with a simpler use case. So for this, I'm going to log into the cluster where this is my own private cluster inside a virtual machine, where I have 2 users, user 002, user 001, and user 002. So both users belong to the same research group, so they have the same group ID, and that lets them read and write to the common group directory in project. And so the first thing that you probably want to do is when you start a workflow like this, you want to configure Git. So I've already done this, but you probably want to configure Git, supply your first name, your last name, your username. And the idea for this is that when multiple people contribute to the same project, you want to see which contribution came from which person, which user, right? And so that way you know how to manage this. And another thing that I find useful is, so a few years ago, GitHub switched the default name of a repository from master to default branch from master to main. And so if you don't want to have any problems when later on maybe you push part of this repository to GitHub, you probably want to default to main as the default name for branch as opposed to master. All right. And so what I'm going to do is I'm going to cd into the common project directory that to which both users can write, right? And so here I'm going to write, I'm going to create a new GitHub repository. I'm going to start with Git first, and then I'll transition to DataLad. And to start GitHub repository, I'm going to do the following. So I'm going to say git init. Collab is going to be the name of the repository. Is going to be stored in this shared project directory. And then I'm passing two very important flags. So the first flag is going to initialize this repository as a bare repository. So bare means that there won't be a working copy of the files there, just the repository itself, right? But no working files. And this is good because in this workflow, both users will copy that repository to their own, project, to their own, Scratch or maybe home directory, and then they will work with a copy of that repository there. So we'll not modify files directly inside this collab repository. And then shared is another really important flag here. So what this flag does, well, actually, let me run this first. So I created the collab directory, but now if I look at permissions of collab, ls-l and then graph for collab, you'll see that permissions of collab have so both users, they both belong to the same group, so the group can read and write files from inside this directory. And then there is what is called the set group ID bit, these S bits, the set group ID bit. When set to S, it actually ensures that when these users, user 01 and 02, create new files, add new files to this collab directory, those files will have the group ownership of dev sponsor 00, right? So that means that both users will be able to read and write and modify those files as well. So we'll start with a simple Git repository. So let me go to home directory of user 001, and then I'm going to clone that repository from a shared directory into a local location, right? So local location is collab, right? Because it just took this name, the default name. And so now I have a local copy, which is just a Git repository. So let me add a couple of long files to it. So here I'm simulating large files. So this command I use it often in webinars. So what it does, it creates a random in Bash is a random integer number from 1 to 32,000 roughly. And then what this will do, it will create a random file called test1. Is going to be a binary file, so basically containing some binary bits. And these bits will be stored in blocks of 1 kilobyte, and there will be this number of blocks. So because random goes from 1 to 32,000, the end result is that this file will have a random size anywhere from 1 megabyte to 33 megabytes. So in fact, if I do ls-l, you see that this file is roughly, in this case, it's 66 megabytes. And then let me add a couple of other files. So here I'm just, simulating putting large binary files. So now I have a couple of files, and all these files are, under 33 megabytes large, right? Oops. Okay, so I'm going to add these files to the repository. Commit them locally, and then I'm going to push it, right? So here we don't have DataLad, we have just a pure Git repository. So here I'm pushing back into the project directory. Okay, then I'm going to log out and log in as user 002, and then that user is going to, in the home directory, is going to clone. He's going to clone collab. So now if he goes into collab, then he has these files, right? These files are not annexed because this is still pure Git, no DataLad, right? But the point here is that he has access to those binary files. He can even, list those files. Of course, they're binary; they contain garbage. But the point is that these files right now are under regular version control. So that user can actually, modify something locally, commit stuff locally. So for example, let me add a new file, readme.txt, and commit it locally. And then I can actually, so here I commit it locally, and then I push, right? And then I push to the central repository. And remember, I was talking about that, that group ID. So project, dev sponsor, and then grab for collab, so that as group ID, it ensures that both users can actually commit to the same repository, right? So let's now transition to DataLad. So now I'm gonna log in, log out as user 2 and log in as user 1. And remember that with DataLad, as I mentioned before, you need to load the DataLad module. And also, I'm going to activate the DataLad alias. So DataLad, I pre-installed it before this webinar into the same shared not repository, same shared directory. So it's under shared subdirectory, right? But the point is that both user 1 and user 2 can actually access that DataLad binary. And then let me remove the old binary from my home. Oh, sorry, old repository from my home. And also, I'm going to remove this collab repository from project. So then I'm going to start from scratch. I'm going to go to project, shared project repository. So there's no collab anymore. And then I'm going to initialize the collab repository from scratch, right? So it was initialized with the --shed flag. That means that this group SID was set properly. And then I'm going to go into my home directory. So here I initialized, again, still so far no DataLad. I just initialized a bare Git repository. And then I went into my home directory. And inside the home directory, I'm going to create a new DataLad repository, right? So I'm going to, from scratch, creating a new DataLad repository using the familiar tags to Git configuration. I'm going to call it collab, right? So same name. Okay. Oops, there's collab there before, I guess. Let's delete the old collab. So here I'm creating a new collab. Okay, so here I go to collab, and now this is now a proper DataLad repository, so because you see DataLad specific subdirectories. And now again, let's simulate adding binary data. So I'm going to have test files, test1, test2, test3. And these files are now, several megabytes, well, all under 33 megabytes large. And now let's add them to version control with DataLad. So that means when I run DataLad save, it will actually store them, remove the file, replace the files with symbolic links, right? So now if I do ls, instead of the files, I actually have the symbolic links. And but they're all active, right? So they're actually pointing to actual files inside the .git annex subfolder. And then I'm going to push that to those files to the central repository on project. But to do that, because remember, at this time, the way I created this local repository is I didn't clone it. I created it from scratch, right? So this local repository actually doesn't know anything about remote. So it doesn't currently have any remotes. So you can to inquire about that, you can either use the git remote command, or you can use the DataLad siblings command. That will show the same things. Oh, sorry, siblings. It will show remote clones, and basically it doesn't know of any remote clones. It knows only about the current clone. So here is the current clone. So basically, what we need to do is we need to add a remote, right? We'll call it origin, and then this remote origin is sitting at this location, right? So now we have a remote called origin, and to this origin, we can actually add files. So let me push to origin. I'm going to run the following command, datalad push to origin data anything. And so data anything means that what I want to do is actually want to transfer all the annex content. And so here I'm doing this. And now if I run git annex, where is test1, there should be 2 copies, right? So one copy is here, I initialize test1 here, and the other copy should be in origin. So when I do this, I actually get 1 copy. And I'm not sure whether this is by design or it's a bug. So I run into this problem all the time. I don't know, but I find that it actually push the data, I need to run this command twice. So now if I run it again, DataLad push, and this is only the first time you work with a new repository. So now it's actually going to push the data. And now if I run the varies command, now you see that there are 2 copies. There is a local copy as well as a copy in remote origin and sitting in this location. Okay, so let's drop a local copy of test1. So I'm going to say drop test1, drop a local copy. And now if I run varies command, now you see that there's only a remote copy in the origin, right, in the shared project directory. Of course, if I want to get a copy, I'm simply running datalad get on test1. Now I have both a remote and a local copy. So let's actually drop all the files for which there is a remote copy. So remember that to inquire about all local files, you can run this command. So all of these guys are stored locally. So let's actually, because all these guys were now pushed into a remote location. So in fact, if I run this, you will see that all of these guys are have a remote copy as well. So let's cycle through all these files and drop a local copy. So to do this, multiple ways of doing this, I'll simply use the bash syntax. I'm cycling through all those files, all local files, and then I'm dropping a local copy, right? So now if I do git annex, git annex find in here, it should not return anything because now all the files are remote. But if I run this command, it will show all remote files. Okay, so now if I run du -s, it will show me total disk usage. It's very small, under a megabyte, right? So that means that those files for sure are not stored locally. So now let's imagine, we want the second user to have write access to the same repository. And but when we run git init --shed on the shared project directory, so this way we ensure that the proper group ID bit was set on the .git repository, right? But actually that did not send the proper ID on the on these two directories, git attributes, and then this file, this directory, this file, and then the .datalad directory. So these guys still in the shared project directory, they still don't have the right group permissions. So I find that with DataLad, I actually have to do it by hand. So you have to set the proper permissions yourselves, but it's actually really easy to do. So as user 01 will give all other users in the group permission to actually contribute to the same DataLad repository. Right? And this is easily done with a chmod command. So now I'm going to log out, and then I'm going to log in as user 2. So let's see if I have the previous version of Collab. Yeah, let me remove the previous version of Collab. So user 2 is gonna so that user needs to load git annex and also initialize DataLad, right? So by defining the alias, and that user also needs to run the following two commands. So these commands will allow Git to work with multiple users, this command will allow the shared Git repository sitting in this location or this location is actually the same link. So this guy is symbolic to this link or vice versa. So this will allow user 002 to contribute to the same Git repository. So this is a fairly recent new setting in Git that was on by default until about a year ago, and then by default they switched it off, so actually now have to enable it. But basically running these commands will allow user 002 to contribute back to the Git repository. So yeah. So now let me clone. Let me go back to home, and then I'm cloning the users 2 copy of the shared Collab repository. And that copy should have the test1, test2, and test3 files. So let's go in there. And now we see there are these files, but in fact, if we try to open it, these files are actually not present here, right? So if I run, actually git annex where is on test1, you will see that this file, that this file is actually sitting on my Collab, which was user 1's copy. So user 1 created a copy, so this copy is not present locally. It's in users 1 home directory, and there is a copy also in the shared project directory, but there is no local copy, right? So to actually get the local copy, you will need to run the datalad get command, which is very easy, right? So now I'll get a local copy of the file, and now I have a local copy right here. So now imagine that you actually want to contribute another file, right? So I'm user 2, and I'm going to contribute the file test4. So here I'm creating this file locally, right? So now I have a new file. I'm going to contribute it locally. So I'm going to say datalad save -m common added test4. Now, if I do git log, you will see now this file was contributed locally. Let me check that I have the proper name of the remote. Great. And then I'm going to push this file test4 to the remote. Okay, so I'm pushing this file to remote, and then I'm running. I can run this command, for example, to list everything that I stored in the remote, right? So now test4 inside the remote, or I can actually run git annex queries on test4, and that will also show that there is a copy in the remote as well. Okay. Okay, so let me also add a simple text file. So here is I added a text file nose.txt. I'm going to commit it locally. And then I'm going to push this file, DataLad push to the central repository. So now I'm going to exit, log out, and then as user2, and then log back in as user1. And now as user1, go into collab. So of course, here, I don't know about the nose.txt or test4.txt. I actually have to update the local directory. And the way, the easiest way to do this will be to run datalad update. So it will update from the remote origin. And there are multiple ways of updating. So you can either update by, keeping only remote files, only keeping local files. Well, I guess that probably wouldn't make sense. But of course, the most obvious thing will be to merge the two versions. So I'm basically taking everything new inside the project directory, and I'm downloading and merging this into the current copy. And I do this with this command. Okay, and git annex. Okay, I forgot to actually load the git annex module. And then now with git annex module, I can actually run this command. And now I will get test4 and nose.txt. And in fact, if I try to view test4, you see it says no such file directory, because in order to actually see this file, I need to get this file, right? And then datalad get actually downloads a local copy, and then I can actually, view this binary file. So I think we're out of time. It's now 3 minutes before the hour, so I think I will stop here. But there's a lot more in these examples. So I find this example really interesting. You have to go through these yourself, and then working with Nextcloud. So you know that we provide the Nextcloud server. Basically, it's online location to store your files and to share these files with anybody else. Very, very convenient. And the way you work with this Nextcloud server inside datalad is you have to first configure a remote. So you will need to install a command called rclone, right? So rclone will when you run rclone config, it will configure a remote, and then basically go through the dialog, and you supply, you describe your Nextcloud, remote, and then you'll have to give your username and password, but then it will store it, in encrypted fashion, so that there's no security problem there. And then basically the way you run this is you configure your Git repository, you add a Nextcloud remote, so it's called special remote in DataLad language. You configure the special remote in such a way that whenever you push to GitHub, the special remote all annex files will go to the special remote, whereas all non-annex text files will go to a GitHub repository, right? And this way you can actually, have, you will not overwhelm GitHub with lots of binary files. So binary files will store elsewhere, but again, you will have access to those files from another machine, for example, somebody else. You can give them access to another machine. And so in the next chapter, I actually show exactly how to do this publicly accessible annex files on Nextcloud. So really easy once you go through all these, all these commands. And it's a really fantastic way to publish very large data sets on GitHub. We actually don't have to store these large files on GitHub because, well, GitHub has limitations. And these files will be stored, on your own Nextcloud storage, right? And then, but the repository that points to those files will still be on GitHub. So you can just give the, URL link to the GitHub repository to anybody, your collaborator, and they will be able to clone the repository and then run datalad get command on a specific file, specific large file that is not stored on GitHub but on Nextcloud, and everything will work nicely. So yeah, so I think I will probably stop here and open the floor for questions.